Let's talk about mass versus weight and how you measure the two things. So here is a block of wood. The mass is a measure of how much stuff is in the block. So how many protons, neutrons, and electrons are in here. That's the mass. How much stuff is in there. The weight is a measure of the gravitational force, how hard gravity pulls down on it. So if I take this and put it on the scale, it's going to give me a reading in grams. And grams is a unit of mass. But this is actually not measuring the mass. It's not even measuring the weight. This balance measures how much it gets compressed. So it's actually reading what we call the normal force, because you can change this really easily. If I take your balance and I accelerate it up, I'm going to get a higher reading. If I took this balance and put it in a space station, it would read zero, right? They would just float around. The gravity is not zero in orbit, but that's what you would get. It wouldn't work. It wouldn't give you the mass and it wouldn't give you the weight. So what this does is it basically gives you the weight if it's stationary and level, and then we can use that to find the mass because we're on Earth and the gravitational field is constant. But what do you do in space? Well, here I have a different device. It's kind of heavy. Hopefully I don't drop it. This is called an inertial balance, an inertial scale. And if I take this and let it oscillate, you can see that it swings back and forth. Now, if I take a 1 kilogram mass and put it on there and let it oscillate, you can see it goes back and forth. You could time that and get a value for that. What if I put another kilogram on top of that? So now I double the mass and I double the weight on Earth, but this doesn't have to be on Earth. So now there's a spring force pushing it back towards equilibrium and it oscillates. The greater the mass, the greater the period of oscillation. And so you can make a relationship between the oscillating period and the mass to find the mass. You don't even need gravity. This is actually measuring the mass. This is what they use on the space station. If you want to find the mass of a person in the space station, you just put this in this thing and you shake them back and forth, just like this. And the frequency of shake gives you the mass. The end. Reach.